Welcome. So we're getting close to a good stopping point, working point. Well, we're getting closer to the end, let's put it that way. And so in this case, we're going to be talking about inheritance. And this is a very interesting topic because there's a lot of individuals that they make this really complicated. But it's really not that hard. I'm not going to say it's not tedious, but it is a topic that does require a little more in-depth analysis on how we use it and incorporate it. So let's jump right in. If I can, yeah, there we go. Cool. So in this chapter, we're going to learn how inheritance promotes software reusability. We're going to learn how to create a derived class that inherits attributes and behaviors from a base class. We're going to use access modifier protected to give derived class methods access to base class methods. We are going to learn how to access base class methods with the base accessor. We're going to learn how to use constructors in inheritance hierarchies, and we're going to learn how the methods of a class object. We're going to learn about the methods of a class object and the direct base class of all classes. And this is a little outline. So hopefully you grabbed your tea, coffee, or whatnot, and we're going to jump right in. So inheritance allows a new class to absorb an existing class's members. I'm going to say that again because that's really the base foundational premise of inheritance. Inheritance allows a new class to absorb an existing class's members. A derived class normally adds its own fields and methods to represent a more specialized group of objects. Inheritance saves time by reusing proven and debugged high-quality software. This is a bit of... This is a bit much. Inheritance does save time. It does reuse code. The proven and debugged high-quality software, I think, is hyperbole, but that's just me. A direct base class is the base class which the derived class explicitly inherits. So, you have a rectangle class. The rectangle class explicitly inherits from shape, where shape can be, any shape. Inheritance allows you to take that shape method and shape objects that are in the shape class and then use them in the rectangle class. An indirect base class is any class above the direct base class in that class hierarchy. So let's say you had shape. So you had shape, and shape was inherited by rectangle. It was also inherited by square. It was also inherited by triangle. But in the case that there's multiple triangles or rectangles, so let's say there's a different type of rectangle called, I forget what that is, the one that looks like this. And then you have different types of triangles, isosceles, you have, whatever the case may be. Well, these are indirect base classes to the shape base class. And they appear in the class hierarchy, but they're not the base class. So in this case, triangle would be inherited by isosceles, because isosceles is a type of triangle, and triangle is a type of shape. If that makes sense. The is-a relationship represents inheritance. For example, a car is a vehicle. As I said, a rectangle is a shape, and a truck is a vehicle. New classes can inherit from thousands of pre-built classes in class libraries, and we do it all the time. Figure 11.1 lists several simple examples of base classes and derived classes. Note that base classes are more general and derived classes are more specific. The reason why is because you want to create your base classes in such a way that they can be inherited more fully by more derived classes. So here's students of base class. We use shape. That's the one I like to use. Loan, employee, and these aren't base classes that are inherent to C#. These are base classes that they wrote for the program that they were trying to, for the other classes that they had in their program. Obviously, shape is not the base class of graduate student, undergraduate students, the base class. And the student class might have specific methods and objects, properties and whatnot that the graduate student and the undergraduate student class would have needed to use. But just know, graduate student and undergraduate student are types of student. And then here's the UML diagram. So as I did, I drew it out kind of like this, you had, you know, the inheritance happening at specific intervals and whatnot. They're drawing it in the other direction. But in this case, the administrator and or teacher is part of the faculty. The faculty is then, you know, an employee, staff's an employee, and then an employee is a community member. You can see how community member would be very community member would be very I'm not looking, the right words aren't coming to me, but community member would be not vague, but more generic. And then as you went down into the derived classes, it would get less and less. It would get less generic and more specific. Give me 1 second. That'll explain it. Jeez, that was loud. Alright, let's keep going. Now consider the shape hierarchy in figure 11.3. We can follow the arrows to identify the is-as relationships. And here we go. You have a shape that then is derived into a 2-dimensional shape and a 3-dimensional shape. And then these shapes are then derived from, or circle is derived from 2-dimensional shape, square and triangle are also derived from 2-dimensional. And these arrows are kind of going the wrong way, but in my opinion, they should be going down. I'm inheriting downwards, right? But triangle is inheriting from 2-dimensional, sphere is inheriting from 3-dimensional, 3-dimensional is inheriting from shape. Objects of all classes that extend to common base class can be treated as objects of that base class. However, base class objects cannot be treated as objects of their derived class. So, the shape class has derived objects, or derived classes in, and we'll do this again, square, okay, circle, and triangle, okay? And these are the derived classes of shape. Shape then passes its methods down into all of these derived classes and its properties. But, and this is why I said those arrows pointing up are kind of misleading, whatever methods are inherent to the circle class are neither inherent to the square class or the triangle class, and those methods are neither inherited by the shape class. This class, the circle class, only contains methods for itself, and vice versa. The square class does not inherit from the circle class, and the square class does not inherit from the triangle class, only from the shape class, and it does not inherit back. This does not occur. It only occurs downwards, from shape to the shape that, or from the base class to the derived class. So, a derived class can customize methods it inherits from its base class. This is called overriding. In such cases, the derived class can override or redefine the base class method with an appropriate implementation. And we do this all the time when the base class's method is too generic and we need to actually add or take away from what it actually does. A base class's private members are inherited by the derived class, but are not directly accessible by the derived class method or properties. A base class's protected members can be accessed by members of that base class, and by members of its derived classes. So, if you only want the base class, so in this case, shape, if you want this shape's methods to be semi-private, meaning that all other classes in the scope of the application cannot access what's in shape, you make them protected. And when you do that, what happens is that it becomes clear that the only classes that can inherit, or the only classes that can access the methods and members of the shape class are the shape class itself and the classes that are inheriting from the shape class. In this case, square, circle, and triangle. Now, once again, protected does not mean private, as you are passing these members down to other classes. But what happens is nothing else in the program can access those classes but what the base class allows to access and the derived classes. Properties and methods of a derived class cannot directly access private members of the base class. A derived class can change the state of private base class fields only through non-private methods and properties provided in the base class. So declaring private fields in the base class helps you test, debug, and correctly modify systems. If a derived class could access its base class's private fields, classes that inherit from that derived class could access the fields as well. This would propagate access to what should be private fields, and the benefit of information hiding would be lost. And this benefit of information hiding is called encapsulation. Very important. The whole reason why we do this is because of encapsulation. So let's look at the commission employee class, and it represents an employee who is paid a percentage of their sales. So here we have the commission employee class. This means inheriting. That's inheritance. The commission employee class is inheriting from the object class. Writing. You then have a list of, a list is the wrong word. You have a set, set's the wrong word. Either way, you have a bunch of variables here. They're all private and they only exist within this specific class. The 5-parameter constructor that is being created here asks for the first name, the last name, the social security number, the sales number, and the rate. And then it adds these specific parameters to the private variables we have in the class. We then create read-only properties that gets the commission employee's first name. We do the same thing for each of the other strings that we have in the class. Now this is redundant. You don't have to do this, but you can. You can just write the property, but I can understand why it's doing that. The property is basically the middleware. What middleware is it's a medium by which you can get data to a specific thing, but the data can only get there through that medium. In this case, the property is created, and then we're expressly telling the property to return the string that we received from the user to the first name, or actually to get. Yeah, right. It'll get the first name object or the first name variable value and then return that outside of the program without you being able to access the private variable first name. Then we have a class called, or a method called gross sales that'll output a decimal. Remember, if there's no void here, that means that it outputs, if there is no void, that means that it outputs a value. And when this gross sales is called, what will replace the gross sales is the output from this method. It's public, meaning that it's accessible outside of this class as well. It gets and returns the gross sales, but then it sets the gross sale based on a variety or a specific algorithm. If the value that gross sales was given is greater than or equal to 0, then gross sales equals the value. Else, throw an exception. Hey, listen, you can't add anything, you can't add something that's negative to gross sales. It's got to be greater than or equal to 0. The same thing with commission rate. And then you have a calculation of the employee's pay using the public decimal earnings method. These are just properties. Commission rate, go back one. Gross sales is also a property. Social security number, first and last name, those are all properties. However, earnings is a method. And what earnings does is all it does is calculate the commission rate times the gross sales. It returns that based on wherever that method was called. You know it's a method because look, there's no parentheses here, but there are argument or parameter parentheses here. That's a property. No parentheses. This is a method. It has parentheses. And then you can override to string. What is override? That means that a base class, object, the object class, had a specific method called to string. I want to change the output of that. And this is what I do. I override that and say, I want you to format my string this way instead. And there it is. A colon followed by a class name at the end of the class declaration header indicates that the class extends the class to the right of the column. Every C# class, directly or indirectly, inherits objects methods. If a class does not specify that it inherits from another class, it implicitly inherits from object. Just know that object is a class. Declaring instance variables as private and providing public properties to manipulate and validate them helps enforce good software engineering. Constructors, they're not inherited. So, either explicitly or implicitly, a call to the base class constructor is made. Class objects default constructor does nothing. Even if a class does not have constructors, the default constructor will call the base class's default or parameterless constructor. So the toString method is special. It overrode the whatever method was being used in the base class object. This override means, hey, I want to change or modify the behavior of a method that I am inheriting. It's a compilation error to override a method with one that has a different access modifier. Access modifier means public, private, protected. Overriding a method with a more restrictive access modifier would break the is-a relationship. If a public method could be overridden as a protected or private method, the derived class objects would not be able to respond to the same method, or to the same method calls as base class objects. Once a method is declared in a base class, the method must have the same access modifier for all that class's direct and indirect derived classes. So don't change the access or the don't change the access modifier. Public, private, protected. Keep it the same as it was in the base class. If you want to change the access modifier, you need to change it in the base class. All right. So this is a representation of what we were trying to do. So we have our main, and we instantiate the commission employee object. See, new commission employee, and it's got the first name, the last name, social security number, the sales number, which is really large, and then the I forget what they called it. Earnings. I think earnings. Gross sales and earnings. Display the commission data, and here you go. It'll display all that data because we fed the constructor through the instantiation of the object all the parameters that it needed. So then what we can do is we can say, okay, employee now contains specific objects, right? The first name is a property that was pulling from the first name private variable. Last name is a property that was pulling from the last name private variable. Social security number was the same. Gross sales was the same. Commission rate was the same. Earnings was a method. But it also functioned like a property. It then set some gross sales and commission rates so that it can be calculated. And here it is. Ooh. All right. So, creating a base commission employee class without using inheritance. We now discuss the second part of our introduction to inheritance by declaring and testing the completely new and independent class, the base plus commission employee, which contains the first name, the last name, social security number, gross sales amount, commission rate, and the base salary base, and the class name standards for the base salary, but not the base class. The base class did exactly what we saw earlier. And here's the base class. We just went over this, but we'll go over it again. We have the base plus commission employee that's got a truckload of private variables that then we are manipulating through our constructor. The constructor asks whatever's instantiating the object, hey, I need you to tell me what these variables are. Fill these arguments. And then what it did was it filled the arguments. Get this out of the way. Can I get it out of the way? No. And then it assigns first name, last name, social security number, gross sales, and the other two, commission rate and base. It's just, rate and salary. Not these, I'm sorry. Yeah, let's fill those as well. You just don't see it when the object is created. Then we have our properties that ask for the variable information or the variable data to promote it back to the program, right? We're not asking for the variable itself. That's important only to the backend class, the base variable or the private variable. What we're asking for is for the private variable to display its information using the property. And it did that for first name, last name, social security number. It also did that for commission rate and salary. Or I'm sorry, gross sales. Right? And then it had the set, right? If gross sales is less than or equal to or greater than or equal to 0, then do it. If it's less than, you need to throw an error. Same thing with commission rate. Throw an error if it's greater than 0. I'm sorry, if it's outside of the scope of, if it's less than 0, greater than 1. And then base salary is the same. It can't be equal to, or it can't be less than or equal to 0. Or it can't be less than 0. And then here you have the earnings method, which multiplies the commission rate by the gross sales and then adds it to base salary and then returns. Remember, there's no void here. Decimal is the data type that it's returning, so it will return a number, decimal. And then we override the toString because we want to print certain things. It's our way. I thought there was more. Okay. Note the similarity between this class and the commission employee. In this example, we do not exploit that similarity. We do not yet exploit that similarity. Base plus commission employee test class. And it tests the class. Okay. And here we go. They ran the test, and it worked. I think we just went over this already, actually. And there it is. It's all the data. It came out just fine. Much of the code from base plus commission employee is similar, if not identical, to the code for commission employee. So why do we write it twice? Right. We shouldn't. What we should do is we should have commission employee as the base class, and then the base employee base plus commission employee as the derived class. Why? Because the commission employee is more generic than the base plus commission employee. The base plus commission employee might have more functions that we actually don't need in comparison to the commission employee, or more methods and parameters or properties. It's more specific than the commission employee. So we'll make the commission employee the base class. Copying and pasting code from one class to another can spread errors across multiple source code files. This is why we don't do it. To avoid duplicating code and possibly errors, in situations where you want one class to absorb the members of another class, use inheritance rather than the copy and paste approach. With inheritance, the common members of all classes in the hierarchy are declared in a base class. When changes are required for these common features, you need to make the changes only in the base class. Derived classes can then inherit the changes. Without inheritance, changes would need to be made to all source code files that contain a copy of the code in question. So, now we need to declare base plus commission employee : commission employee. Boom. Now base plus commission employee is inheriting from commission employee. Now guess what? We don't need all those variables anymore because we already have them. They are already being used through the commission employee class. And here we go. So the constructor is asking for string first name, string last name, the social security number, sales, rate, and salary, but it's getting that information from the base class. Fancy that. So now all we really need is a parameter for the base salary. And there it is. If it's less than 0, hey buddy, you got to put your base salary in there. And then we have our override for decimal earnings. Remember that there was an earnings method in the base class? We're overriding it because we want to add the base salary to it. But remember, we can't do this because we're trying to access private variables. In order for us to do this, we're going to have to change those access modifiers to what? Protected. If we change the access modifiers in the base class, in the commission employee, if we change all of these access modifiers for the variables that we instantiated, that we initialized, to protected, then the base class will allow the derived class to access those variables. But right now we didn't do that, so it's not allowed. This is not going to be allowed either because of the same problem. All these are going to have access modifier errors. There you go. Cannot override inherited member because it is not marked virtual, abstract, or override. Override. Virtual is actually a very important thing as well. I don't know if we're going to go over that, but maybe we might. A base plus commission employee object is a commission employee. A constructor initializer with keyword base invokes the base class constructor. So if we say base, like you saw there, right? Let's go back one. Like you saw here, colon base. We're basically saying I also want you to invoke the commission employee constructor as well. A compilation error occurs if a derived class constructor calls one of its base class constructors with arguments that do not match the number and types of parameters specified in one of the base class constructor declarations. So, let's talk about these access modifiers. The virtual and abstract keywords indicate that a base class method can be overridden in derived classes. I'm going to say that again. The virtual and abstract keywords indicate that a base class method can be overridden in derived classes. So, the base class had a method called earnings. Let's go back. Right? But it was public decimal earnings. There's a problem there. It doesn't take into account whether or not the commission employee will have their salary or have this earnings method overridden. In order to override this, we have to create the earnings method in the base class as a virtual method. When we do that, then what happens is that the methods... Oh, give me one sec. Stop. There. When we do that, then what essentially happens is we allow for the base class. The base class allows all its derived classes to be able to modify the base class method whenever needed. And in this case, it would need to be modified. But because we didn't say this needs to be virtual in the base class, it's not going to work. All right. Let's keep going. The override modifier declares that a derived class method overrides its virtual or abstract base class method. This modifier also implicitly declares that derived class method virtual. We need to declare commission employees earnings method virtual. Remember, if we don't declare it virtual, then we can never use it, or we can never override it. We can use it, but we can only use it the way that it's being passed from the base class. The compiler generates additional errors because base class commission employee instance variables are private. We talked about that. The errors can be prevented by using the public properties inherited from the commission employee. Or we can just give those variables a protected instead of using the properties. But properties is a good idea too. And here we go. Inaccessible due to its protection level. That's the access modifier error. It's telling you, oh, it's private. You can't use that. Class commission employee is a modification of the version in figure 11.4. We also declare earnings method virtual. So I'm not going to read this. I just want to look at it now. Let's look at it and see what it looks like. All right, so here's the base plus commission employee, and it all kind of looks the same. Okay, let's go back really quick. So there's one private decimal, base salary. We inherited all the variables from the constructor of the base class commission employee. And now that we have base salary, we need that information. So we're going to get that information through the instantiation of base plus commission employee. Then we create our base salary property. All right, and we add a catch-all for the set statement. Then we override the earnings to add base salary, and we override the string because we wanted to add base salary to the string. Ooh, was that the wrong? Interesting. Oh, well, I guess they didn't show us commission employee. I wonder why not. Okay. So base plus commission employee object to perform the same task that performed on the version of class 11.6. And here's the main, and it instantiates base plus commission employee with all the information that it needs: first name, last name, social security number. But it's using the constructor of the base class to ask for all that information. The only thing that base plus commission employee constructor really wants is this. And then it does all the work. And the output looks like this. So, using protected instance variables creates several potential problems. The derived class, remember, when you have a base class and derived classes, the base or the derived class can only use the base class variables if those variables are marked as protected, but there's issues with that. The derived class object can set an inherited variable's value directly without validity checking, meaning that the derived class can modify base class variable values without understanding the ramifications of doing that. That can cause wide-scale problems with your program. Derived class methods would need to be written to depend on the base class's data implementation, meaning that you're at the mercy of whatever the base class is telling you it needs to do. Those are the two different problems with using protected instance variables between the base class and the derived class. You should be able to change the base class implementation while still providing the same services to the derived class. Declaring base class instance variables private as opposed to protected enables the base class implementation of these instance variables to change without affecting derived class implementations. What's an implementation? An implementation is what's written in the class. So an interface, as I said in chapter 14, the interface has the ability to there you go. So, the declaring base class instance variables enables the base class implementation of these instance variables to change without affecting derived class implementations. Implementations are the written code, the method with the statements written inside it. So, for instance, if I go back and show you, this is a abstraction. This is an implementation. The implementation is what actually does the work. Interfaces do not require you to write implementations. As a matter of fact, it'll be a compiler if you do. So let's look at this for a second. This is the commission employee base class with all private variables. Then it creates a constructor that asks you for the base information that the employee will need to calculate commission. It then takes that information on the concrete instantiation of this constructor, and it assigns those values to the private variables that are accessible to this class and this class only. It then initializes properties to access those specific values. So get, we've seen this 3 times already, but we're going to go over it again. Get first name, get last name, get social security number, and return it from the variable that we assigned it to in the constructor. Then gross sales does what it did before. It returns gross sales from the variable that we assigned at the constructor, the private variable that's accessible to the class. And then we have a set value if statement. If the value is equal to, and we went over this already as well. Same thing with commission rate, and here's earnings. Commission rate, the property. Notice that's the property commission rate. That's not the variable commission rate. And that's very important. The property commission rate times the property gross sales. Why do you think they did that? Because the property is what's going to be accessible outside of the base class. You don't want your variables that are private to the class accessible outside of your base class. This allows for the derived implementation to not modify, to a great extent, the private variables within the earnings class or within the commission employee base class. And look, they added virtual to allow for that method to be overridden. And then they overrode the object method to string. The class base plus commission employee inherits from commission employees and can access the private base class members via the inherited public properties. So, what does that mean? So the base class has private variables, but we don't want anything other than the base class to be able to access them. But the derived class, base plus commission employee, will need those values. How do we get them? We have properties that, and they're public, that we are displaying to the derived class that can get the value of the private variable. That's how we're doing that. And here we go. We'll go over the base plus commission employee inherited from the commission employee class again. We only need to initialize the private decimal base salary because all the variables that we want are already in the base class. We don't have to rewrite them. We're just going to inherit them. Then we define how we want the base salary to operate. So in this case, I want you to get the base salary value whenever the base salary property asks for it. And I want you to set that value, but only set that value if the value is greater than or equal to 0. If it isn't, throw an error. Then I want you to override the decimal earnings this time. And I want you to use the base salary property. That's the property, not the variable. And I want you to do that and add that to base.earnings. What's this? What is this? What do they do here? Well, what they did was they took the base class and they used it like an object. And they said, hey, listen, there's a method inside your thing called earnings. I want to use that. But I also want to add it to the base salary that we're trying to calculate. That is the way you should do it. Use the methods in the base class so that you don't have to rewrite what the implementation of that method is. And that is the purpose of inheritance. So the base salary property is being added to the base.earnings method, which, if we go back to the base class, here's the base class, and here's earnings. Public virtual decimal, what is the base class earnings method calculating? Commission rate times gross sales. But we don't have to write that again. It's already there in the base class. All we really have to do is override that method and say, yeah, I know that's what that does, but what I really want to do is I want to use this earnings method name again, but this time what I want is I want you to run the earnings method that's in the base class and then add the output to the base salary that we have in the derived class. And then I want you to output the base salary class information while I override the toString object. When a base class method is overridden in a derived class, the derived class version often calls the base class version to do a portion of the work. That's why we override it. Failure to prefix the base class method name with the keyword base and the member access operator dot when referencing the base class's method with the derived class version causes the derived class method to call itself, creating an infinite recursion. What does that mean? Well, if you're overriding a method, so you normally override a method when you want to kind of use the same thing. So override x. But I mess up and I don't say base.x in here. I actually just said x. What I'm essentially doing is calling this method over and over and over again. And over and over and over again. And over again and over again and over again. Because what's going to happen is it's going to run. It's going to say, oh, I got to run this again. And then it runs. Oh, I got to run this again. And then it runs. Oh, I got to run this again. Because I didn't give it the prefix base, saying I want to use the base method, not this method. Because you can call the method you can call a method's name inside itself. You can implement the method's name inside itself. There are times where you want to do that. Very rarely, though. So, the base plus commission employee test performs the same manipulations on a base plus commission employee object as did figures 11.7 and 11.11. By using inheritance and properties, we have efficiently and effectively constructed a well-engineered class. I can agree with that. That is a valid statement. And here we go. So, the base plus commission employee test looks something like this. Public static void main, you have the base plus commission employee, and then you have all of the work that it needs to do. And then it looks something like that. And boom. The base salary commission is now inheriting from the commission employee class. Notice you have all the commission employee data plus the base salary data with it calculated on top of all the other information that's here. A derived class constructor, before performing its own task, invokes its direct base class's constructor. This is done either explicitly, meaning outwardly, or implicitly, meaning naturally or inside. If the base class is derived from another class, the base class constructor invokes the constructor of the next class up in the hierarchy, and so on. When a new class extends an existing class, the new class inherits the members of the existing class. We can customize the new class to meet our needs by including additional members or by overriding base class members. Independent software vendors can develop and sell proprietary classes. Users then can derive new classes from these library classes without accessing the source code. So things like DevExtreme, where you can download their libraries and then just instantiate their classes or use their classes with loosely coupled dependency injection. And then from there, I don't have to really access their source code. I'm just either inheriting or I'm promoting their code through service providers, which is something I'm not going to go into right now. Although inheriting from a class does not require access to the class's source code, developers often insist on seeing the source code to understand how the class is implemented. This is very important. They may, for example, want to ensure that they're extending a class that performs well and is implemented securely, or so that we understand that the class was written correctly. In this case, writing base classes to derive classes correctly is integral. Effective software reuse improves the software's development process. Object-oriented programming facilitates software reuse, potentially shortening development time. The availability of substantial and useful class libraries help deliver the maximum benefits of software reuse through inheritance. At the design stage in an object-oriented system, the designer often finds that certain classes are closely related. The designer should factor out common methods or common members and place them in a base class. Then the designer should use inheritance to develop derived classes, specializing them with capabilities beyond those inherited from the base class. And this is what we do all the time. We try to find out, okay, we have a lot of classes that do the same thing, right? Rectangle. You kind of look at what the least common or what the common denominator is. You have a rectangle, you have a circle, you have a triangle. What makes all of these things, what is common across all of these classes? They're shapes. You have an undergraduate student, you have a graduate student, you have a high school student, you have an elementary student. What's common across all of them? They're in school. They do homework. All their students. Here goes one. I have a football player, I have a basketball player, I have a soccer player. What's common across all of those? They're athletes. So I'm going to have a base athlete class, and then derived from that athlete class, I'll have my derived athletes, which is football, baseball, basketball. And you can do that anywhere. You can do that with anything. You can do that with cars. You can do it with TVs. You can do it with financial documents. You can do it with anything. Just understand that there's always a common denominator. Whatever that is across all your classes, you take that and you make it your base class. This completely shrinks the amount of written code you actually have to write. You write it one time. Declaring a derived class does not affect its base class's source code. Inheritance preserves the integrity of the base class. The way we wrote it, it actually does. We're not accessing the private variables, we're accessing the public properties. We're not changing the method that we inherited from the base class, we're overriding it to create a new version of that method. But that doesn't change the base class. The base class still remains the same. And that's the way it should be. All classes inherit directly or indirectly from the object class. Remember, the object class's constructor will always fire, even if it's not being explicitly written. So, and here are some methods: equals, finalize. There are classes that contain destructors. Not going to go into that. But we talked about destructors and garbage collection. Getting rid of objects in RAM. Destructors are more important in C++, as C++ has buffer overflow problems. And so just using the buffer can really cause you a lot of problems. So destructing methods is very important, or destructing classes is very important after you construct them. Here are some more methods that are in the object class that are inherited directly or indirectly by all classes. ToString, that's a big one. Big one. And that's it for this one. There is also another chapter that I'll be doing today and I want to upload, but just understand that things can get quite hairy. And inheritance can look really daunting, but it's not. It's actually really, really simple. It can be tedious if you don't design what you need to design correctly in the beginning. If you wait while you're developing to do this design, you will run into a hash table full of problems. So, that being said, hopefully this was very informative and it helped you. If you have any questions whatsoever, feel free to reach out. Otherwise, ciao.